Good morning, and thanks very much for your time. I really appreciate it. We know people are busy, and we appreciate you taking the time to come and join us for our presentation today. My name's Craig Peterson, and I'm the CASA Aviation Safety Advisor for the Western region. I work out of the Perth office. And as an aviation safety advisor, my role is to do things like this, to coordinate and run these safety presentation events. And hopefully we all get something out of it and things that we can incorporate into our flying to help move things along in a safer direction. Great to have you with us there, Peter Robinson. We can see you there. If you wouldn't mind muting your video, that would be really much appreciated. It just helps everything run smoother. So, ladies and gentlemen, our session today is aimed at increasing awareness of the hazards that we face at non-controlled aerodromes. And in particular today, we're going to be looking at that interaction between smaller private type GA aircraft and our larger aircraft that are carrying passengers into those non-controlled aerodromes. Now, why do we want to talk about this? Well, the Australian Transport Safety Bureau data tells us that 3/4 of our reported conflictions, if you like, with traffic or separation breakdowns occur within 10 nautical miles of the uncontrolled aerodromes in Australia. And I'm sure that'll come as no great surprise to you if you're flying around in that environment. Now, most of those separation issues are the result of poor communication. We know how important communication is in that environment. But there are other factors that sort of contribute to this as well, and to make that non-controlled aerodrome environment quite a hazard-rich environment. So we're talking things like a diverse traffic mix with respect to aircraft performance. We've got a diverse mix of pilot experience, which contributes to the conflictions as well. And also we know that some of those non-controlled aerodromes can be quite busy, so we've got a lot of traffic. Another thing that the ATSB data tells us is that in Australian airspace, our biggest risk of a mid-air collision is on base and finals at a non-controlled aerodrome. And again, I don't think that will come as a big surprise to most of us. So if we look at all those things combined, we can see that that is really a hazard-rich environment, and we really do need to be careful when we go in there and think about what's happening and what everyone else is doing. So we really don't want collisions occurring. Any mid-air collision obviously is undesirable, but if we're talking about now a potential collision between a small aircraft and a passenger carrying aircraft, that becomes even more catastrophic, and it's certainly something that we want to avoid at all costs. So after today, our discussions today and our presentations today, what I'm really hoping is that the pilots of lighter aircraft and the pilots of the heavier air transport aircraft have a better understanding of the safety issues faced by the other group, and that all of us leave with some practical measures that we can incorporate into our flying on a day-to-day basis that will make flying at those non-controlled aerodromes much safer. I'm also hoping that we all leave today just with a reminder that safety is a constant state of vigilance. We can't rest on our laurels. We do have a good safety record in this country, but it's because we actively seek to look forward, assess the risks and hazards, and try and mitigate them when we can. And it's really important we stop every now and then, like we are today, to just remind ourselves of what those hazards and risks are and what we should be doing to basically make things safer. I hope you walk away with one or two things that you think you could work on in the future. We're lucky to be joined by some representatives of some of the major carriers today, as well as some representatives from RA Oz who have kindly joined us. They'll be giving us some information about their operations in non-controlled aerodromes, and they'll also cover some of the issues that they face with respect to safety. We're really grateful for their time. They're obviously very busy at the moment, and I'll introduce them as we go along. They'll give us a quick presentation, and then after each of those quick presentations, we'll have a short question and answer session. And then at the end of the three presentations, we'll just open the floor up to a general Q&A session. And hopefully you don't walk away today without an unanswered question. So this is a pretty big Teams meeting, and I just want to cover a few domestics that are going to make things run a little bit smoother for us. We would dearly love to be able to get everyone together in person, but obviously we're coming from all around Australia. COVID considerations and all that are in place at the moment. So this is what we're left with, but we can make it work. It just takes a few little things to keep it running. So yes, questions at the end of the each session. We'll have a couple, and then we'll, if you've got any others, we can answer those at the end. You can also ask questions in the chat window. If you're familiar with how to use that, you just open the little chat box. It's a button at the top of your screen, and you can type in a question as well. And I'll have Michael White, my colleague, monitoring that. So let's get underway with our first presenter. And our first presenter is Andrew Learmonth. He is the Qantas Fleet Safety Investigator. And handing over to you, Andrew.
Thanks, Craig. Thank you very much. And g'day, everyone. Just give me a moment while I share my screen and get this up and running. And yeah, Craig, let me know if you can't see that. Yeah, assume that's all good. Excellent.
That looks good, mate.
Great. Thank you very much. Thanks for the introduction. My name's Andrew Learmonth. I'm a captain at QantasLink. I fly the Dash 8 Q400s and also work within the Qantas group as a fleet safety investigator. I've been with QantasLink for about 7 years, and prior to that, worked at Virgin Australia flying ATRs for about 4 years. I was a check and training captain on Metros before that, and prior to Metros, spent a bit of time as a Grade 1 flying instructor as well as GA. So a fair bit of time operating in and out of non-towered aerodromes, and I've had the perspective from a lot of different views. So not only as a GA pilot, student pilot, instructor, but also now from the airline side of things. But that's really enough about me. Let's get on to talking about non-towered aerodromes. Just got a bit of background noise in my headset. I think a couple of people might just need to be muted. As aviation ramps up, I guess from the pandemic we've had the last couple of years, we're seeing more flying at non-towered aerodromes, and I guess that's a good thing. We're flying more, and also we're seeing more and more of you flying out there as well. So hopefully everything stays that way and we can continue flying and no more lockdowns or anything like that. But I guess there's also a consequence to that. That ramp up in flying has increased the likelihood of airborne conflict. Basically at QantasLink, we want to work with the industry as well as local operators to try and help the reduce of airborne conflict, and also understand any challenges that you are having along the way and during RPT arrivals. So to help local pilots such as yourself understand, I guess, QantasLink operations and get a bit of an insight into RPT operations, which will be reinforced by Ben from Virgin shortly, this presentation is going to cover a few main points. The first one is the typical Dash 8 arrivals, how we typically will arrive at a non-towered aerodrome, including what the benefit is of runway-aligned approaches. We're also going to I'm going to talk about previous conflict events we've had at non-towered aerodromes and what everyone could have done a little bit better to try and prevent that. And I'm also going to talk about how we're teaching our pilots to separate from other aircraft at non-towered aerodromes. And there might be a few things that you can take away from that yourself. So I guess before I get too far into it, for those that aren't as familiar with the Dash 8s, we operate into all the eastern states as well as South Australia. We've got two main types of Dash 8s. We've got the Dash 8 400, also known as the Q400. So that's our bigger one, 74 people, and weighs just under 29 tonnes. And I'll talk about why that weight's important in a sec. It'll cruise pretty quickly. It's about 350 knots, but probably what's more applicable to you is our speeds below 10,000 feet. So below 10,000 feet, this aircraft will do about 235 knots. So that's about 4 miles per minute. So it's getting along about double the speed of a Cessna or a light aircraft. And similar on approach as well, our final approach speed will be about 130 knots. So that can be 60 or 70 knots faster than many light aircraft, again, double the airspeed. When we're operating these Dash 8 Q400s, we'll use the call sign like QLink 164 Delta. And the Delta bit at the end indicates it's the faster, high-performing Dash 8. Now, I mentioned earlier that the 29 tonnes was something I wanted to mention. I guess there's a couple of things there. The weight of the aircraft means we can't use certain taxiways at airports. And also we might actually have to roll through to the end of the runway and use the turning nodes before we vacate. So sometimes we get local operators get a little bit frustrated why we're using certain taxiways or have to use up all the runway. It's usually because of the aircraft's weight. And the other thing to consider too is being 29 tonnes, it's a medium category aircraft when it comes to wake turbulence. So all I'd suggest is if you are following a Dash 8 around the circuit, just maybe give it a little bit of space. You may get a bit of wake turbulence from it. The other common Dash 8 that we fly, and just to go back a step, the Q400s we typically fly in Queensland and New South Wales. whereas the Dash 8 300s you'll see in South Australia, Victoria, Tasmania, and bits of New South Wales as well. It's slightly smaller, only 50 people, and weighs just under 20 tonnes. But under 10,000 feet, very similar speeds to the QF100. It's still going to do about 4 miles per minute in the descent and have a final approach speed around about 115 knots. So these slightly lower performing Dash 8s, they don't use the call sign with the delta at the end. It'll just be something like QLink 164. So how will our Dash 8s arrive? A common way is they'll join via a circuit. So if we are going to join via a visual circuit, in line with the AIPs, we will join the circuit at 1,500 feet above aerodrome level. When we are joining downwinds, typically it'll be at about 160 knots to 190 knots, depending on the type of Dash 8. So typically that higher speed will be on early downwind, and then as we configure on the downwind leg, we'll start to slow, and as we put our gear and flap and whatnot. Spacing from the runway to make it all work will be about 2.5 miles from the runway, and usually about 40 seconds from passing a beam the runway, we'll start that base turn. So typically to intercept around a 2 to 3 mile final, we'll be turning final about anywhere between about 600 to 900 feet. So that's the visual circuit. What's actually very common though is that we will fly an instrument approach, which will put us onto a straight in approach for a runway. So using the Wagga example over here, this is an example of an RNAV approach or an RMP approach. And I'm not going to break down the chart. It's a lot to go through and it might be a little bit hard to see on your screen there. But this is a typical RNAV approach into this case here, Wagga runway 05. So all an RNAV approach or an RMP approach is it gives us a series of waypoints, GPS waypoints that we cross at a particular height, and it basically puts the aircraft on rails. It lets us fly a nice, consistent approach all the way into a straight-in approach. So typically, we'll start one of these instrument approaches via one of these initial legs here, and we'll do that at about 5,000 feet above aerodrome level. We'll slow down to below 160 knots by the time we get to a 5 mile final. And therefore, if you consider it all, it takes us about 5 to 6 minutes to do this instrument approach before we land. How that translates, if I overlay this with Wagga Wagga Airport, we might come in, say, from Brisbane or somewhere north, and you can see it takes us out to the west of the airport onto a 10 mile final and a nice, straight, consistent approach into land. So the instrument approach, like this, it's probably the most common way that we will arrive at an airport. So you might be asking yourself, why does QantasLink, as well as other RPT operators, do these straight-in approaches, these runway-aligned straight-in approaches? And I guess when I was early on in GA, I used to think that pilots doing straight-in approaches were maybe being a little bit reckless, or maybe they're just trying to save time, maybe they're a cowboy. But as I've sort of gone through the industry, I've learned that there's actually a number of benefits to flying a runway-aligned straight-in approach, particularly for your larger RPT aircraft. So the data's shown that 3D runway-aligned approaches are safer and they result in more stable approaches for us. And there's a number of other benefits too for RPT aircraft. I guess the first thing is the ability to join instrument approach that allows us to descend beneath the cloud and get visual with the airport. So that's probably the primary reason that we will fly an instrument approach. But also, as I explained earlier, the approach basically keeps us on rails. It allows a consistent flight path, and that allows us to manage our speed and inertia a lot better. It's also all hooked up to automation, so that makes it really, really easy for us to fly, and that gives us time to concentrate on other things, process information better, and improve our situational awareness, particularly when it comes to looking for other traffic at non-towered aerodromes. For us too, it's predictable flight path, and that makes it predictable for you. Hopefully you know where we are. If we can broadcast on a 10 mile final to runway 05, that makes it a lot easier for you to understand where we are. What we've found too is that flying these sort of approaches actually allows safer separation from circuit traffic as well as training areas. So usually we're well above training areas, but also because we're not joining a visual circuit, we're not overtaking aircraft or anything like that. It just puts us on a final leg where it goes into a point I'll cover shortly, where it makes it easier to spot and identify other aircraft in the circuit. For us too, it's actually easier to navigate and find the aerodrome. If I'm going to an airport that I haven't flown to before in the Dash 8, I'll fly via instrument approach and it lines me up really nicely with the airport and it makes it easy for me to spot and everything like that. And lastly, better flight deck visibility of circuit traffic. And here's what I mean here. So here's a picture of one of our crew flying the Port Macquarie. It was actually taken from the jump seat, so it's a slightly better view than the pilots actually have. But what you can see is that there's a lot of stuff in the way. We've got, I guess, glare shields, overhead panels, quite a large glare shield in front of us that you've got over. So you've really only got this window out the front. Out the side, we can't really see much past about a 90-degree position out to our left. So you can imagine having a view like that and joining a circuit with multiple aircraft in it. It can actually be very, very difficult for us to see anyone, particularly if they're below us or above us. And again, that's one of the reasons why this straight approach can be quite good. We can see if you're out on a downwind leg or an upwind leg or something like that, gives us time in a nice straight line to try and pick you up. So there's a number of safety advantages with these runway aligned approaches, but the only issue is there's a slight disconnect with the CASRs. And you may have come across this. I'm not going to go through it in detail, but what it basically says is for a straight in approach, you need to know what the wind direction is at the aerodrome. And we do that. We'll listen to the AWIS or some other method to determine which way the wind is blowing. And that allows us to then understand the runways in use at the aerodrome, as well as when we listen in the CTAF. And we'll usually start listening in well before we broadcast to get an understanding of what circuit traffic are doing. Also, the CASRs say that we've got to complete all of our manoeuvring on final before 3 miles. And we do that. Most of our pilots will join at a minimum of a 5-mile final. But if they're doing an instrument approach, like I showed you before, it's well before that. They'll be on final at about 10 miles. The bit that causes a little bit of an issue, though, is that the bit that says an aircraft must give way to other aircraft flying in a circuit pattern for the aerodrome. And that's where it can become a little bit tricky for us with that requirement to give way to other aircraft. What we have been seeing recently with the increase in flying, particularly at aerodromes where there's a lot of flight training going on, is increased occurrences where we're having other pilots turn in front of the Dash 8. So they'll turn base in front of one of our Dash 8s on final. And as Craig said earlier, that's one of the highest risk areas for a mid-air collision is that base and final sort of area. So aircraft have been turning base in front of the Dash 8s, and it could be for a few reasons. It's always hard to know, but it could be because the pilot believes they have right away. But it could also be that that pilot was unaware that the Dash 8 was coming in on the final near them. In these occurrences here, it's resulted in several go-arounds from our crew to sort of get out there, then they've had to reposition for another approach or some other way to arrive. Now, due to the large speed differences, it's actually almost impossible for the Dash 8 to fly a circuit if there's multiple traffic doing their circuits as well. So you can imagine, as I said earlier, we're doing double the speed of many light aircraft. If you've got 2, 3, 4 aircraft also doing circuits, it's just about impossible for the Dash 8 to try and fit in that circuit as well. Again, that's why we love the straight-in instrument approaches. So I guess what I'd like you to take away is despite circuit traffic legally having right of way, all we're suggesting is that let's work together to make the arrival sequence work for everyone. We're not saying that you have to give way to us or anything like that or get out of the way. Let's just work together. And probably the most important bit is that first bullet point I talk about there, confirm the intentions of the other aircraft and determine early on who will be number one. So if you know that you're going to be on downwind wanting to turn base, you know the Dash 8 or an RPT aircraft's out there, just speak up, establish that communication and work out who's going to be number one for the arrival. Doesn't always have to be us. Sometimes it works really well if you actually go number one, but that communication is important. Other options could be consider adjusting your circuit profile. Now that might not always work, particularly if you're a fairly inexperienced pilot or you're doing circuits at night or something like that. But is there an opportunity for you to maybe extend your downwind, to do an orbit, something like that, to help the other aircraft out? Again, that depends on the situation. Another suggestion could be reduce your speed or configure a little bit earlier. And we might do that in the Dash 8 if we know that we're going to go number 2 to you. We'll put out our final stage of the flap earlier, slow down and allow you to go number 1. But all that relies on communication and confirming the intentions of the other aircraft nice and early. So Stepping aside for a moment, we did an analysis into, I guess, breakdown and separation incidents we had between 2019 to 2021 to try and understand, I guess, if there was anything we could do better as a group to avoid issues. So we went through, we reviewed all of our incidents we reviewed the incidents and we looked at something called the TCAS RA, which I'll explain shortly. But what we found was three main causes of a breakdown in separation between our aircraft and other aircraft on the CTAF. The most common one was a clear separation plan was not determined by the flight crew. So the Dash 8 crew knew the other aircraft existed, the other aircraft knew the Dash 8 existed, but they didn't communicate. They didn't come up with a plan to say who was going to be number one, who was going to be number two, if someone was going to maintain a height, if someone was going to fly a certain way to avoid the other one. No plan was determined. They just sort of continued on with the mindset that, oh, it'll be right. And it didn't end up being right. The second most common cause was an initial plan was determined, which was really good, but there was no follow-up by either set of pilots to see if the plan was still appropriate. So for instance, you might speak to the other aircraft and you work out that, okay, they're going to be arriving 3 minutes after us, all good, we're going to be number one. But there was no follow-up to see that that ETA was actually correct. There was no follow-up to check the other aircraft's position, their distance from the airfield. And if there was that follow-up, it might have allowed the opportunity to determine that the plan wasn't going to work out anymore and to come up with a new plan. And the last common reason why there was a breakdown in separation at the non-towered aerodrome was the other aircraft either didn't broadcast on the CTAF or they just didn't follow their communicated intentions. So for instance, they might have said that they were going to remain to the north of the field, then they actually flew to the south of the field. So not following the communicated intentions. So I said, use the term TCAS earlier. I better describe that quickly, what that means. Not everyone may be familiar with it. It was a great system that was introduced in the 1980s, and TCAS stands for Traffic Collision Avoidance System. And what it does is it uses, TCAS uses transport returns to provide pilots with advisory and avoidance information. And all of our Dash 8s are fitted with TCAS as the most higher performing aircraft. What it basically does is, based on the transponder returns, the TCAS calculates
Okay, I think we just got some problems with Andrew's video there. We'll just try and sort that out and keep moving. We'll try one more time and then we'll move to you, Ben. Andrew, can you hear us okay? Got your microphone muted there. No worries. Okay, well, what we'll do then, ladies and gentlemen, is we'll try and get Andrew back a bit later in the presentation, but now we'll move to Ben van Dongen. And Ben is the Virgin Boeing 737 Fleet Training Manager, and we want to welcome him today. Thanks, Ben.
Thanks, Craig. Also joining us today, ladies and gentlemen, is Scott Mitchell. Can you see that presentation there? Oh, Scott's come up on the screen. Yep.
Presentation looks good.
Very good. And I'll let Scott introduce himself from our side.
Hi everyone. Thank you very much for including Virgin here today. I'm the Air Traffic and Meteorology Manager. Joined Virgin in January of this year, but prior to that was at Air Services for a bit over 12 years in a variety of roles. So, but really passionate about aviation and safety, and look forward to more of this to come. So I'll hand back to you, Ben.
Thanks very much, Scott. So just to give a way of my background, so at the moment I'm the fleet training manager on the 737, which is keeping us pretty busy as the days go on. My background, I've been with Virgin on the 737 and only on the 737 for just coming up on 20 years. Throughout that time, though, I've also done volunteer flight instruction. I've got a current grade 2 flight instructor rating. And prior to Virgin, I was operating in GA throughout Queensland and New South Wales. So again, even while I've been operating the 737, I've had a fair bit of exposure to non-controlled airspace and non-towered aerodromes as well. So I'd just like to give you a bit of a rundown, following on from what Andrew said about some of the things that we see at Virgin. one of the interesting things that's happened even post-COVID, but our exposure to non-towered aerodromes and non-controlled airspace has probably reduced quite a bit over recent times, just simply due to the network structure that we operate. So when we look on the east coast of Australia, really the only non-towered aerodromes we operate to on a regular occurrence are essentially Ballina, and now with the SFIS, and Proserpine. Our exposure to non-towered aerodromes obviously increases over in Western Australia with a lot of the mining ports that we operate to over there as well. And obviously when we're running off schedule in and out of towered aerodromes where the air services are no longer provided outside those hours. So I just wanted to follow on, I suppose, from what Andrew's been talking about with regards some of the risks that we encounter at non-towered aerodromes from a crew perspective. You can still see all that, I presume. Yep. So it's one of those things, as Andrew has mentioned, some of the risks that we see, they're pretty much the same for all of us here on this call, which is, we encounter a mix of aircraft performance, and that can be anything from 152 general aviation training all the way through to such as us with 737s, or even if you look at WellCamp with 747s and A350s coming in and out with freighters. Obviously, see and avoid limitations is a risk associated with it. And even when you look at that photo, that's a 737 on approach with me on the jump seat coming into Port Vila a couple of years ago. And as much as the view out the front is a very good one, you can see it still is a little bit limited with the amount of glass that we can actually see out of. And lastly, the communication, radio interference, common language, all those sorts of things. And I'd just like to run through a few of those as we go along. So a bit of background about 737 performance, just from a arrival and departure, so arrival more perspective, is a typical descent profile for the 73 and most jet aircraft, including the A320. When you're looking at below 10,000 foot operations, to give you an idea, when we're working out our descent profiles and our distances to run, essentially what we look at is about 30 miles out from the airport, we're doing 250 indicated. Now at that point, our maximum speed is 340 indicated, but our AIP compliance kicks in, so we're at 250 knots, and we're going to be sitting at about 10,000 feet on descent. As we get closer and closer to the airport, though, once we're inside about 20 track miles to run, so that's not necessarily 20 miles from the actual aerodrome reference point, that's 20 track miles to run on the approach. We're looking at about, we commence deceleration generally at about 5,000 feet, and we commence that from 250 knots. At about 10 miles to run, we're sitting back at generally about between 180, 200 knots, and we will be at 3,000 feet. And from that point on, we only really slow down maybe as slow as we go is generally about 130 to 135 knots, depending on weight. So we don't generally lose too much more speed in that last 10 miles of the approach. Bit of a rule of thumb for you, from an altitude perspective, when we're looking at calculating our profile, we generally look at a 3 times profile. So if it doesn't quite work on my 10,000 foot example there, but if you're looking at 5,000 feet, 5,000 times, or 5 times 3 gives me 15. I need to decelerate from roughly 250 knots back to 200 knots. And we account for that with about an extra mile to lose 10 knots of airspeed, which is why 250 knots, 20 nautical miles at 5,000 feet works out pretty well for us on those sort of profiles. So as you can see, we are moving fairly quick until we get inside about that 20-mile point, and when we start commencing our deceleration. So when we are planning our arrivals into places such as Proserpine or the non-towered aerodrome, we take a fair bit of time to set up and plan for the arrival, and we've got it programmed into the flight management computer. The flight management computer takes care of pretty much everything for us, which is nice, including it monitors our vertical profile, and the autopilot can provide input to the vertical profile as well to fly the path that we set up. But it also sets, we can also put in a pre-programmed LNAV track, or a track for us to fly on the way into the airport. Now, predominantly, we do look to fly instrument approaches in most instances, and certainly following on from what Andrew said, in the lack of an instrument approach, if conditions are such that we will fly, that we can fly straight in approach, we will generally opt for that as well. We don't fly to too many places where we get an opportunity to fly a full visual circuit, and in those circumstances, where we might do that for the purposes of managing our arrival, it's again very limited at the ports where we are able to do it. And I'll talk about some of the meteorology, met conditions that we use when when our crews fly visual circuits. So as I said, generally speaking, we'll be setting up for an instrument approach of some description, and all of this setup starts occurring at about 200 nautical miles out when we start loading up the FMC and briefing for the arrival. And that's one of the things that I'll talk about shortly, is managing the workload as we approach non-towered aerodrome, and the ability to make last minute changes to that plan that we've got. So we've got our Class C, Class G speed limitations. We've also got our instrument approach speed limitations. You can see the chart there at Proserpine for Cat C and D. We'd be back at 210 knots over the top of the VOR. And in our case, that's probably going to be closer to about 6,000 or 7,000 feet in altitude as we fly that profile, because we're aiming for a constant descent profile. So whilst I said earlier 250 knots, 5,000 feet, 20 miles, in that instance, we'd actually be quite high, but we'd also be quite slow as we fly around the approach. Remembering that's really only running around at about 3.5 to 4 miles a minute to fly that whole approach. One of the other things that we have, which is not just limited to non-towered aerodromes, it's also for all aerodromes that we operate to, is that we do have a speed limitation in place for crew to comply with at 210 knots below 3,000 feet AFE. So the aeroplane, irrespective of the distance out, all crew will be back at least to 210 knots once they get below 3,000 feet above the field elevation as they approach the circuit. So when it comes to communication, we encourage our crew, obviously standard calls per AOP, that's a given. But what we also encourage our crew to do is be fairly proactive in communicating with everyone on this call when they're operating in the vicinity, and try and make sure that everyone's aware of our location and what our intentions are. And we have a statement in our operations manual that actually says that they should be doing that with reference quadrant and distance. So it removes any of the ambiguity associated with instrument approach plates, instrument approach waypoints and things like that. So hopefully you won't hear our crews tracking to some random waypoint on a RMPAR approach that is not the simplest to work out exactly where it is. Rather, we encourage them to give the quadrant and distance from the ARP. We have a couple of additional calls just to make sure crew that there's an awareness coming into the circuit, in that we ask the crew to make a 30 and 15 mile call. Now 30 miles out seems like it's a long way, but when you're looking at it, general speeds from 30 miles, we're generally only about 6 to 7 minutes, or 6 minutes, 7 minutes maybe away from being within the vicinity of the aerodrome. And we have a requirement that for dual frequencies, both pilots must be monitoring the common frequency at all times and be on the listen out and the lookout to make sure that they pick up any traffic that might be becoming in conflict. We also have, just lastly, a requirement that we ask the crew have to broadcast on the area as well. So for those of you who haven't quite reached the area of the non-towered aerodromes and you're still maybe 20, 30 miles out, if you're monitoring the center frequency, you'll often hear us making a broadcast a couple of minutes before we enter Class G airspace on the way down. And as already discussed, it's a regular thing, because we understand that not everyone understands instrument approach plates. We understand that it's far simpler if we give a bearing and distance, and that way everyone knows where to look. So on approach selection, as Andrew's alluded to, we have fairly stringent stabilised approach criteria that all crew must comply with at all times. Now, for our stabilised approach criteria, we have it from it commences at 1,000 feet. The approach must be stable, but most unstable approaches commence well before that, which is why that a lot of crew will opt for an instrument approach procedure rather than a visual circuit in a lot of instances, just due to workload management for both flight crew on the way in. For us at Virgin, we put a visual circuit restriction on. So if you've ever see cloud ceilings below 1,500 feet or visibility less than 8 kilometres, you won't see one of our company aircraft doing a visual circuit, i.e. joining downwind to fly 3 legs. They will be tracking via an instrument approach into a non-towered aerodrome in those visual conditions. One of the notes that the 7.3 is capable of doing, which I'd just like to bring to attention, it's not at all ports. It's only at limited numbers of ports, such as Ballina is a good example, Hamilton Island when the tower's not active there. We will often set up and fly for an AR approach, so the authorization required approach. And if you look at the example on the screen there, when you look at, say, Hamilton Island 843 or 842, which are the waypoints there, they don't mean much at all. So if our crew are saying tracking to Hamilton Island 843 for the RMPAR approach, it doesn't mean anything really from a bearing and distance to anyone listening to that call. Hence why we encourage and push the crew to make sure they give it a quadrant and distance rather than using those waypoints. Because as you can see from that diagram, an RMPAR isn't just this 5-mile final. It actually loops over the top of the airport. It says over on it, it crosses at 4,000 feet there. But in actual fact, you can be a lot higher depending on the altitude restrictions on the approach. And as I said, this drives us into a safer position a lot of the time with instrument approaches because we are able to stabilise the flight path, we are able to meet our stabilised approach criteria, and we actually improve our visibility once we get around the corner because it allows the crew to have a lot more SA to be able to look outside the window because they're comfortable with where the aircraft is, the flight path, it's all being managed by the automation generally on these sort of approaches, which opens up their SA and their ability to look out and listen out for other traffic. So see and avoid, when we look at some of the limitations that I'm sure everyone's here has had experience with the limitations of see and avoid. Even I remember learning to fly at Toowoomba, I had a couple of fairly close calls with that one with a couple of CTAF frequency changes. But we mandate that the pilot flying, whoever is flying the leg of the aircraft, must spend a minimum of 50% of their time looking outside. So we don't want the crew heads down in the cockpit. The pilot monitoring will have to, but we certainly want the pilot flying outside. We also talk about with the crew in our training packages is the use of exterior landing lights. The 7.3's got 4 landing lights on it, 2 of which are retractables, and it's actually got 6 with turn-offs. And I encourage crew to use as many of them as possible to improve visibility on their way in. And lastly, which Andrew got to before he was rudely cut off by Microsoft, was the TCAS is a tool. And for us, it's a very handy tool because we can see the traffic, we can see where people are going if their transponders are on, but it is not the primary method of separation. It's the last line of defence in all circumstances. Primary lines of defence for us are clear and concise communication with everyone and separating if we need to vertically or laterally as required. The TCAS is just there in case that doesn't work. So I know I've been fairly quick, but that's about all I've got to talk about from an overview. So Craig, I'll hand back over to you if you.
Thanks very much, Ben. That was fantastic, really informative. We did get a couple of questions in advance, and if I may, I'll just ask you one from our list of the advanced questions.
Yep.
With respect to aircraft calling clear of the runway after landing, is that beneficial for you guys as you're coming in?
It can be depending on what sort of approach we're flying, because when we're on an AR, so certainly an AR approach, if we're on an ARC, we might have limited visibility with that sort of traffic, and depending on the size of the aircraft that's calling clear as well. I mean, a 737 at Ballina is a little bit more difficult to miss when it's still sitting on the runway. But certainly I've seen examples in other airports where a wide aeroplane on a white threshold marking who's about to vacate very quickly disappears. So I think it's up to if the person is concerned that they may not be as visible on the ground, or if they're concerned about the separation that they've got with arriving traffic, certainly a clear of the runway call just gives a bit of comfort to us on approach to make sure that we are sure that they are clear of the active strip and we're right to continue if we can't see them.
Thanks for that, mate. And one more, just that came from our RPAS pilots. With respect to RPAS who are operating under an approval close to a non-controlled aerodrome, is it sufficient for them just to make broadcasts of what they're up to, or is your preference to actually have them on frequency and being able to communicate with them? Has that come up much at any of the fields you operate into?
We haven't had too much of those. The generally speaking, the RPAS events, and Scott might be able to talk to this a little bit more. I mean, I've seen an RPAS on approach in Sydney at 4,000 feet a few times. Having said that, we haven't seen too many of those at non-towered aerodromes as such. From an RPAS operating perspective, if there's a radio communication available and required due to their proximity to the airport, my suggestion would be to at least monitor as much as possible, and if in any doubt, make a broadcast, because sometimes we could spot the lights of the RPAS and sort of go, what the hell's that doing here? And it might just be the difference between us wondering why it's there and just knowing that it's there to start with.
And Ben makes a good point there for all sorts of operations and non-controlled aerodromes. Communication is the key. If you're communicating clearly what your intentions are, then that's going to be better for everyone in that environment. So, ladies and gentlemen, I'll open up to the floor now. If we could take maybe one or two questions, if any has any, for Ben, you can just raise your hand with the little hand button if you've got a question. Otherwise, we are going to go back to Andrew and continue with his presentation. So I'll just give people a couple of seconds to indicate if they've got any questions. All looks good at this stage. You can always ask them at the end of the presentation, or I've put my email address in the chat. If you think about something later on that you want to ask, feel free to send me an email. So Andrew, good to have you back, mate. We got up to just when you're explaining what TCAS was. So I'll hand back to you to finish the rest of your presentation.
Thanks, Greg. Yeah, sorry everyone. Sorry about that. The joys of Teams. I'll just go back a step. And let me know again if everything freezes up. I think we're back up and running again correctly. So before I was cut off, just talking a little bit about I guess breakdown and separation events and why we saw they did occur. And just to recap very quickly, the common themes were either a clear separation plan wasn't determined between the different sets of pilots, so the external aircraft as well as the RPT aircraft. Second one was a plan was initially determined, but there was no follow-up from either aircraft to see whether the plan was still appropriate. Well, the last one was really just broadcast on the CTAF either were non-existent or the plan that the two crew came up with wasn't followed. So then we got into talking a bit about TCAS, which I explained a little bit about, and Ben mentioned as well there. But yeah, the traffic collision avoidance system in a nutshell we spoke about was it uses transponder returns to try and work out whether another aircraft is a collision threat, and it uses this closest point of approach to determine where a collision could potentially occur. So really, the thing we want to get across is the TCAS is the last line of defence to prevent a mid-air collision, and it's not something that can be relied on just to separate from other aircraft. We'll get a return on our displays to show where the aircraft is. The altitude readout's really accurate, but the vertical, I guess, lateral position, I should say, the lateral position isn't very accurate. So you can actually jump all over the place. So we can't use this for separation alone. So the way that the TCAS system works is it effectively calculates, I guess, bubbles around the aircraft. So first of all, let's just think about this yellow bubble. If it works out that the other aircraft is anywhere between 20 to 48 seconds from a potential collision, it'll give what's called a TA, or a traffic alert, a traffic advisory, I should say. So that's just basically telling us that, hey, there's traffic out there, and that draws our attention to it. If you come within the second bubble, the smaller one, the red one here, it shows you're only as far as little as 15 to 35 seconds away from a collision. So that's obviously a lot higher risk now, a lot closer the two aircraft will be to one another. And that's where the resolution advisory will kick in. And if we hear this RA, it means we actually have to maneuver the aircraft. It's a requirement. And if this happens in controlled airspace out of interest and the controller tells us to descend, but the TCAS tells us to climb, the pilots have always got to follow the TCAS instructions. So TCAS, TAs and RAs, yeah, they are a big event. It shows you're getting very close to the other aircraft's, I guess, bubble of safety there. So probably the most important tool to avoid getting into, I guess, a separation breakdown event or possibly a TCAS situation is really it's effective radio communication. It's vital for us and you to help manage your traffic separation at non-towered aerodromes. Ben spoke about this, and it's something that we talk to our pilots about, but it's using plain English when broadcasting. So we encourage our pilots not to use IFR waypoints. I remember prior to my own IFR flying, I'd hear someone say that they're at, I don't know, Dubbo, Sierra Echo. I don't even know if that's a waypoint, but you'd hear something like that and you'd think, where the heck is that? You've got absolutely no idea at all. So we're encouraging our pilots to use, something like a compass quadrant, so a bearing and a distance to say, hey, they're 15 miles to the east. That's much easier for other pilots to understand than an IFR waypoint. And in a similar, I guess, theme, we'd encourage VFR pilots not to use local landmarks or other VFR waypoints. I know if I fly outside of Queensland and I go down towards, I guess, southern New South Wales, Victoria, I've got no idea where a lot of local landmarks are. So if someone communicates that they're overhead a lake or something like that, I might not know where you are. So that's why we're really encouraging the use of plain language and possibly those compass quadrants to explain your position. I guess too, a lot of pilots, and I know I was like this when I was learning to fly, you just think the radio's there to broadcast your position and that's it. But it's not. The radio's there as a tool for you to not only listen out for other aircraft's positions, but also, I guess, to work out the other pilot's intentions and come up with a clear separation plan. So we'd encourage you to do that too. If use the radio to probe the intentions of the QLink crew or the Virgin crew or whoever it is, if you're not sure of what they're going to do, and come up with a separation plan. So a bit more about managing separation. Unless our crew are, I guess, are visually separated from another aircraft or they have some sort of horizontal separation assurance, our crew are required to maintain 1,000 feet of vertical separation. Now that may sound like a lot to you, but 1,000 feet's what we really need given the higher rates of climb and descent that we can experience, as well as the TCAS system. We need that to try and avoid a separation breakdown. So in order to meet those, I guess, separation assurance requirements, our crew may contact you on the CTAF to come up with some sort of separation plan. And I guess mutual separation means it's got to be appropriate for both aircraft. So if, I guess, anyone contacts you on the radio and comes up with some sort of plan and it's not going to work for you or it's unsafe due to weather or terrain or your own limitations, just speak up. Just say, we're happy to hear that. We'd rather we hear, what your limitations or anything are, and we can come up with a new plan. And I guess with that, we want people to be assertive and come up with some sort of separation plan on the radio if needed. But we told our pilots not to be pseudo air traffic controllers. We don't want them up there telling you where to go or you must go here. That's definitely not encouraged, and we don't want any of our pilots doing that. But that's different to coming up with some sort of mutual separation plan. That is encouraged. So a good example, let's say I'm inbound from the south and I'm inbound to an aerodrome and I hear another aircraft has taken off and they're departing in the opposite direction to the south. And I see that there's possibly going to be a threat there. We could cross paths. That's where speaking up on the radio may be appropriate. So it might go along the lines of this. Alpha Bravo Charlie, QLink 160 Delta, we're passing 9,000 feet on descent. Are you able to maintain 4,000 feet until we pass? We'll stop our descent at 5,000 feet. So you can see we're coming up with some sort of plan, and for us, that's 1,000 feet of good separation until we're horizontally clear of each other. But we're not telling you have to do that. It's just coming up with a plan and seeing if that's going to work for you as well. And if that wasn't going to work, speak up. We can come up with a new plan. So to wrap up, other strategies we're teaching the QantasLink pilots is, it's been a theme here, use the radio as a tool, seek clarification from the other aircraft about their position and intentions, and don't just make assumptions about where they're going to fly. We're also encouraging our crew to take a conservative approach, and if they need to, delay the arrival or delay the takeoff if they're not happy that they're going to have, I guess, appropriate separation from other aircraft at the non-towered aerodrome. And I guess a couple of final points, final feedback to everyone listening out there. Really, just speak up if you're unsure of our intentions or our location. I know it can be a little bit daunting to speak up on the radio if you hear a commercial operator, but we really would love to hear from you if you're not sure what's going on. And the last thing, Ben mentioned this, and I think Michael mentioned in the comments, please switch on your transponder and make sure it's set to alt. We can't see you on TCAS or anything like that if your transponder's off. And that could be the first little clue that there's an aircraft out there that we need to get in touch with. So please switch on your transponder. That's it. That's it for me. I'll leave my email address up there on the screen. I guess if you do have any questions or feedback about our operations or anything occurs down, you might work for a flying school or an operator at an aerodrome that we fly to regularly, and you want to just clarify something, there's my email address. Happy to speak to you about that. But in the meantime, Craig, were there any questions for me? Sorry about the delay and two parts to this presentation.
No problem at all, mate. We get that often on Teams. That's not a problem at all. Thank you so much. That was a really good presentation. We did get a couple of questions in advance, if I can. With respect to visibility of other aircraft, turning lights on, landing lights, etc., in the circuit in day VFR conditions, does that help you guys out with respect to identifying the other traffic?
Yeah, great question. Yeah, it definitely does. It's actually the lights draw your eye to it, particularly if you're turning on a landing light or a taxi light. We usually can see that before we can actually see the aircraft due to the everyone's visual acuity in their eyes. So yeah, definitely that would be helpful, and it's actually part of our SOPs that we have all of our lights on as well, so you can see us a lot sooner.
Fantastic. Another one from someone who sent one in. Do you guys always include your aircraft type with your CTAF calls?
Yeah, as part of the AIP recommended calls, yeah, it talks about type, and from what I've observed, people will say -8. Now they might not broadcast -8 in every single radio call, but definitely in the inbound calls and the positional calls, they'll say that. But they're unlikely to say their aircraft type when you're making up follow-up clarification radio calls, anything like that. Yeah, I think most people do make that, and it's from our end, we love to hear what aircraft type you are as well, because that builds a picture in our mind as to your potential speed, performance, that sort of thing. So yeah, aircraft type, yeah, big thumbs up. Keep saying that on the radio, everyone.
Thanks, mate. One point I wanted to highlight to the people joining us today that both Ben and Andrew have mentioned, it's about the straight-in approaches and the stabilised approach. The data from around the world, not just Australia, shows us that with larger aircraft like this, a straight-in approach that allows the pilots to get that stabilised approach criteria with respect to rate of descent, configuration, airspeed, results in much safer operations. It's a big deal for a large aircraft to have to do a visual circuit compared to, say, a light aircraft. So Andrew did make the point that, there may be times where you do have the right of way over an aircraft that's coming in on a straight-in finals because you are established in the circuit. But good airmanship would dictate that if you can, it's a really good idea to give way to them regardless. And of course, you'd communicate that clearly to make sure everyone's clear with what's going on. So they were really important points brought out in both those presentations. Ladies and gentlemen, is there anything from yourselves? If you have a question, this is the time where you can raise your hand and ask a question. Otherwise, we are, sorry, got one from Ian in chat there. Ian asks, I fly paraglider with a Sky Echo 2 EC device, and although I don't fly in proximity to aerodromes, what would show in your cockpit when it is turned on? So can I ask that one of you, say Ben?
Sorry, just coming back on board. So if we're in proximity and close enough to you, because the TCAS system itself has limitations around how high and low it looks for traffic, because it's not looking for all traffic. It's not like an ADS-B where it's just throwing it out. The transponder itself, the TCAS system, is only looking within certain limitations so that it doesn't clutter our screen either. So if you were within that range, what we would see would be, if it's got altitude out as well, we would actually see a hollow diamond on our screen. If there's no altitude associated with it, it would just be a hollow diamond and we wouldn't have any altitude reference. If it had altitude associated with it from your device out, we would actually see how high or how low you are away from us with reference to our current height. So that's what we would see on our screens, and that's how we would identify. So often coming over the top in Sydney is a good example. If we get traffic on the ground at Bankstown, they might not yet be squawking with an altitude readout, and all we see is just a hollow diamond on our screen. If we go anywhere near them, as we get closer and closer, those symbols change. Ian said it's ADS-B, so we don't have, and I'm pretty sure Andrew's the same, we don't have ADS-B in or out on our aircraft, in on our aircraft. We do have ADS-B out, ADS-B in, so we don't actually see anything other than what's on it coming out of a transponder.
Thanks for that, Ben. Alan, your microphone's actually open already, Alan Mallows, but you look like you've got a question there. Did you want to go ahead?
Yes. Can you hear me?
Yes, I can.
Good. Yeah, look, I'm a student pilot, and I'm particularly concerned about low hours and in CTAF areas. And one of the controversies from where I fly is that recently it was heard on the radio the words, "I'm not giving way to the likes of you." Now, of course, obviously, we just simply extend downwind as far as possible, get out of the way of this very belligerent person. But is that a reportable thing?
Thanks, Alan. If you wouldn't mind muting your microphone there again, that'd be awesome. And thanks for sending that question in advance to us as well. I think we all know, I think pretty much everyone in the chat today can answer that question. That's just poor airmanship. It's not the type of communication that should be taking place. It can result in conflictions, and I would certainly be reporting that communication. If you don't wish to give way to someone, there's polite and professional ways to say it. And that's not the way to do it. So yes, I would be reporting that to CASA, and we can take it from there. So thanks for that question, Alan. And we do actually get reports of sort of unproductive and inappropriate communication reasonably regularly, and we try and act on those if we can. Thanks for that, Alan. You can deselect your hand there. Was there anyone else who had a question at all? Just wait and see. Looks clear. In that case, I'm going to introduce Cody Calder from RAOS. He is the head of safety, and Cody is going to give us a presentation today. Over to you, Cody.
Thank you very much, and thanks to everyone who's joining in today, and of course CASA for holding this position at this presentation. With me, I've also got Jill Bailey, who's our head of flight operations, and the two of us will be tag teaming a little bit in terms of our presentation today. Some really valuable stuff there from the airlines, especially from the perspective of those in the GA and sport world as to the considerations from their point of view. We wanted to touch a little bit on the light end of the town and what we're seeing in our world. So from my perspective, I'm the head of safety at RAOS. I've been with RAOS 4 years now, and before that was flying charter and parachute operations in New Zealand and Fiji. And with us, we have our head of flight operations, Jill Bailey.
Thanks, Cody, and thanks everyone. It's a great audience listening in on this. It's a very hot topic, and it's an important topic because that's where everyone meets, is at the aerodrome. My perspective, I've been with RAOS for 11 years now, and I've been flying since 1999 in various capacities and enjoying the role of head of flight ops with RAOS. So I'll hand back to Cody. We'll tag team, as he said, for the rest of the presentation.
Thanks, Jill. So to start off with, what we've done is just had a little bit of a look at the RAOS data that we've had reported through our accidents and incidents over the last 5 years in relation to airspace related incidents and incidents and accidents at non-controlled aerodromes. So over that 5-year period, we've seen 170 airspace related accidents or incidents, of which 96 occurred during flight training and 74 occurred during private operations. So 56% of those in flight training operations. Obviously, they're spending a lot of time in the circuit. Now, out of those 170 airspace-related accidents or incidents, 89 were separation or near-miss occurrences in non-controlled airspace. Of those 89, 74% of those occurred within the circuit. So 3/4 of those occurrences are happening within the circuit. And from the data, a near-miss event was a contributing factor in at least one fatal accident over that 5-year period as well. So when we look at our near-miss or loss of separation events from the data that we've got at REOS, 33% of those 89 involved procedural issues, 13 involved conflicting circuit directions, 11 involved gliding, parachuting or helicopter operations, 7 involved incorrect frequency or a total failure to communicate, and 6 involved overtaking in the circuit. But what stands out most when we look at our occurrences at REOS is that most of these occurrences may have been avoidable through improved radio communications between traffic. And all occurrences that were reported, all aircraft were equipped with radio, despite the fact that in some airspace, a radio is not required. All of the occurrences that we saw were equipped with radio. So when we have a look at where near-miss events are most likely to occur, they're most likely to occur at airports with increased traffic density, also where there's different operation types or varying aircraft performance, whether that be gliding operations, parachuting operations, helicopters, IFR or warbird operations. And often we see them occur at airports in close proximity with another airfield or in quite complex airspace where there might be quite a lot going on. And that map there is just a breakdown of our near-miss occurrences over the last 5 years. And as you can see, our more built up areas, there's a lot more of those occurrences that take place. Handing over to Jill.
Yeah, thanks, Cody. I'll just talk a little bit about the types of aircraft and some strategies that our pilots can employ. But I do want to call out the presentations from Andrew and Ben. They're really informative, really helpful to understand what it is that goes on in the Dash 8 world, the 737 world, because there are airports where our types of operations mix. So in terms of RAL's operations, generally our aircraft will fly reasonably close gliding distance circuits. And that's purely a risk management strategy because we have a reduction in gliding distance as low inertia aircraft. It's surprising to a lot of people that a lot of our aircraft actually have quite new avionics. They've got the G3 Garmins and all sorts of whiz-bang glass cockpit information. There's a lot of ADS-B in and out available on many RAL's aircraft. And as Ian Clark, our colleague from SAFO, mentioned, you've got the Sky Echo EC devices, which are starting to pop up and become very useful as well. A lot of our aircraft are being used in the type of operation that eventually is moving that pilot towards commercial. So there will be some variety of aircraft use, some variety of training conducted. But we've got 3 aircraft there as typical examples. The powered parachute on the left, pretty coloured parachute there, is going to be operating at 300 AGL. And very close to the circuit because of its lack of glide capacity. It's generally going to be operating very early in the morning or late in the evening when the calmer conditions tend to be around, and not particularly fast. You're talking about probably 35 knots as an absolute maximum for that aircraft flat out on a good day. The middle aircraft, the weight shift microlight, is going to be operating between 500 and 8,000 AGL in the circuit, again remaining quite close for gliding distance, can manage stronger wind conditions, but again will be within a much tighter circuit pattern than you might be expecting for a typical GA aircraft. And interestingly, in our 3-axis aircraft, the final photo there is of an aircraft that cruises at 200 knots in the RAL's sphere. So that is a high performance aircraft. It's hooting along. And while not all of our aircraft are going to be operating in that regime, there's anything from 55 to 200 knots. So that does present some challenges to pilots as well to know what it is that they're expecting to deal with. And those aircraft will approach anywhere between, as I said, 35 to 80 knots. So quite a wide speed range as well. So from our perspective, in terms of flight planning, for our pilots, Cody, if you can go to the next slide, our expectations in terms of our pilots and our operations are exactly what is in legislation, flight planning to ensure that you're aware of what would be happening at the airport. But part of that would include or should include considerations of what sort of pilots and aircraft will be operating when you're flying into an airport you're not familiar with. So we've talked about passenger transport, we've talked about gliding operations, parachuting, circuit training, warbirds, helicopters, emergency aircraft, aerial application. The whole gamut is what you're going to find in a non-controlled aerodrome. So some of the considerations we'd like our pilots to consider would be tracking the activity in the area. There's plenty of software and applications out there that allow you to see what's going on electronically. That does not remove the need for see and avoid with the good old Mark 1 eyeball. And confirming that you're on the correct CTAF frequency, listening in early to what traffic is going on at that airport, use your AWIS and other traffic activity to also determine what to expect in terms of the circuit you could expect to arrive at. And when you're arriving, take a leaf out of our bigger brothers and sisters operating in RPT, do a sterile cockpit, put away your EFBs and use your alerted see and avoid processes to focus on traffic and build the picture. One of the key things I like to talk about, particularly with our pilots and our instructors, etc., is what are the other pilots' needs? So I've learned a lot today from Andrew and Ben about what RPT need, and I was aware of the general expectation of straight-in approaches being much simpler, much more manageable for bigger aircraft. But let's have a think about those sorts of things in terms of our abilities as RALs pilots to interact. So from the perspective of a straight-in approach being the easiest for those pilots to manage from visibility issues and manoeuvring, let's not forget that those pilots are flying our families in and out of airports. So we want to make sure that we're not going to get in their way and give them the courtesy they deserve when we're operating in those combined operations. You can consider contacting the airlines or looking at the airlines for timetables. So you could plan your arrival to avoid the high peak times of arrivals with the RPT, particularly at places like Mildura, Dubbo, Wagga, Ballina, where there's a lot of activity with a lot of high-speed aircraft. You could call the ARO at the airport based on the ERSA information and have a chat about what type of traffic volumes you could expect. You could schedule your arrival potentially to be away from those times. For gliding operations, obviously, they're very focused on the launch. That can cause some gridlocks at airports while they're taxiing out behind cars, etc. And also when they're coming back in from competitions, they can have competition finishes which result in aircraft coming through quite a high speed just to try and get to the arrival point and win the competition. So again, reading NOTAMs, being aware of the sorts of activities from our gliding brothers and sisters, thinking about the types of launches that are being done at those airports, from a winch launch to a tow operation, very different types of operations, very different and exciting sometimes to watch those launches going on. Parachute operations, obviously, we're talking about long periods where nothing seems to be happening because the aircraft's climbing to a decent altitude and then throwing out the parachutists, and then everything starts happening very quickly. So obviously be considerate there and consider just holding short of the airport, doing a couple of laps in an orbit and allow the parachutes to land on the ground. We're not in that much of a hurry, or we shouldn't be, that we can't just afford a 5-minute orbit while parachutes land. And when it comes to circuit training, as Cody said, we have noted a few instances where pilots have cut in front of others. It's not good airmanship, it's not professional, and just because we're not being paid to fly doesn't mean we can't act professionally. So talking about managing your position in the circuit, maintaining your position relative to other aircraft in the circuit, and just being professional and thoughtful about your interactions. Not forgetting too that we're all students once, and we all remember the overload that occurs when you're first flying circuits as a student. You're trying to remember what the heck to do in the aircraft, and you're also being expected to potentially maintain situational awareness and make radio calls. So just be a bit considerate about students. They're under a bit of stress. The instructor can also be under a bit of stress because they're trying to manage the student and their own situational awareness. From the perspective of warbirds, we don't necessarily mix up with warbirds all that often, but if we're flying into an air show, or an event where there's displays going on, we're going to have aircraft that potentially might have poor visibility on the ground while taxiing. They might have overheating issues if they're on the ground waiting for someone to get out of the way so they can depart. They could be doing abrupt manoeuvres if they're performing any sort of aerobatic display. So obviously, perhaps consider your arrival and departure times at air shows for the same reason. And aerial application pilots are obviously doing fast turnarounds, quick departures, and may not necessarily be departing on the interwind runway or arriving on the interwind runway, and doing low departures and arrivals. So good comms with any of those pilots will solve a lot of the problems. So going on to the next slide, I'm pretty sure Ben and Andrew have pretty much covered this really well. Certainly, as I said, learned a lot about how RPT operations tend to try to manage their operations, but consider, as I said, your planning when you're arriving in an airport with RPT. Consider leaving the circuit or extending downwind or delaying circuit entry to allow that RPT to come in. Might be flying your family member in from a holiday, so you don't want to necessarily cause them any issues. And communicate. So you know, a lot of our pilots are quite nervous about communicating with RPT or other pilots, but if you can't remember their call sign, just calling them QantasLink or Virgin will get their attention. And it's far better to do that and establish that communication than not say anything at all. And Michael White from CASA talked about the wake turbulence considerations. There's a heap of guidance available for any pilot on wake turbulence, and we've got AC 9116 there as an example of reading up on wake turbulence to make sure you're not going to end up in a little bit of exciting moment while approaching. Next slide, thanks Cody. We're talking about standard operating procedures. The reason they're standard operating procedures is because everyone's expected to follow those procedures. Don't do something that's unexpected without at least communicating that you're going to be doing something a little different. But, you know, Part 91 Plain English Guide and all of the procedures that are in AIP and URSA are there for a reason. It's not going to take us any much more time to fly a full circuit than it will be to just try and do a sneaky dive in on a runway to try and avoid other traffic. That's not really the answer. And again, communicating, broadcasting positions, as Andrew and Ben both said quite rightly, relative to the airport. Just as we might not know the IFR waypoints, the IFR pilots don't know where Fred's farm is, but they certainly will know if you're 5 miles northwest. So common terminology and relative bearings to airports and distances will be useful. And the last, there's a comment there from Michael. Yep, there's the link for that AC. Thanks, Michael. Alerted see and avoid is a really critical part of flying into non-controlled aerodromes. You shouldn't assume because you haven't heard calls that there's no traffic. And obviously there's requirements in 91 for you to make calls as necessary to ensure the risk, reduce the risk of collision with another aircraft, and that you must broadcast in the vicinity of an aerodrome if you're equipped with a VHF radio. So, you know, it's there for a purpose. It doesn't cost any money to use a radio to communicate your position, and it may just help you to sort out a separation issue with another aircraft, be it RPT or whatever other activities going on. I'll hand back over to you, Cody, unless there's questions on that.
Thank you very much for that, Jill. I just wanted to wrap up with a couple of occurrence examples, but obviously to point out that the point of these is not to apportion any blame, but to use as a learning opportunity. So the first one that I wanted to use was on the 28th of November 2020, a Jetstar A320 was conducting an approach to land at Ballina Airport. At the same time, an RAL's Jabiru was transiting from Heckfield to Evans Head. Now, the two aircraft flight paths intersected 12 nautical miles southwest of Ballina Airport with a vertical separation of only 600 feet and no lateral separation. So you can see from the image there, the crossing two paths. And when the ATSB investigated, they found that the Jabiru pilot was not aware of the location of the A320 until their paths converged. And likewise, the crew of the A320 was also not aware of the Jabiru aircraft until they received a TCAS alert. Both aircraft were operating on the CTAF frequency and both aircraft had been making radio calls, though neither aircraft recalled hearing the radio calls of the other. What the ATSB found in relation to contributing factors was the transponder on the Jabiru was not selected to transmit altitude data, only position data. So they were selected to mode A, not alt, on their transponder. The Jabiru pilot did not recall hearing the broadcasts of the A320, and the flight crew of the A320 did not recall hearing the broadcasts from the Jabiru. And more information on this occurrence can be found on the ATSB website with their full report also. But since that occurrence there, air services have implemented a surveillance flight information service at Ballina. Ballina now has its own specific radio frequencies, and other CTAFs in the areas have updated frequencies, and radio calls at Ballina are now mandatory. But then when it comes to that flight planning perspective, recently we received an additional report of another occurrence where a pilot transited through Ballina without realising that those changes to the airspace had occurred. And weren't aware of the new requirements in terms of making radio calls in that space. So planning, communicating and listening, especially in relation to this occurrence where both pilots were communicating on the CTAF, but were both going to different destinations, so weren't necessarily listening out for the other. The second example is between two light aircraft within the circuit. On the 28th of January 2021, an aircraft was downwind for runway 12 at Caboolture Airport, following another aircraft downwind. Now, the aircraft that it was following was conducting wide circuits, so the aircraft behind communicated with that pilot that they intended to pass on the inside of them on a close base to land number 1. Now, that aircraft conducted a passing manoeuvre on the inside of that aircraft in the circuit, but failed to identify that there was in fact a third aircraft that was established on final for runway 12. That aircraft became established on final directly above the other aircraft, and neither aircraft saw each other. Thankfully, they were notified by another pilot that was in the circuit who noticed the two aircraft, one above the other, who was able to communicate with them over the radio, and the aircraft that was above the other managed to conduct a go around. So our review of that occurrence identified that aircraft A conducted a non-standard procedure by passing the other aircraft in the circuit. In doing so, they didn't identify that there was another aircraft that was established on final, and the aircraft that was established on final was also not identified as making regular radio calls. So again, standard procedures and circuits and standard altitudes are best put in place to protect aircraft from a near miss or collision in flight. Deviation from these procedures greatly reduces likelihood of being seen and increases the likelihood of one of these events taking place. Clear two-way communication greatly increases situational awareness, and lookout is always the last line of defence. We should be avoiding distractions and have our eyes outside when we're in the circuit, rather than focusing too much on what's going inside. And that includes, like Jill mentioned, closing our EFBs, being planned for the circuit before we get to the circuit so that we can be eyes outside. There's obviously been a lot of communication about TCAS today, but also in relation to ADSB. For those who aren't aware, as of the 12th of August, the Australian government are offering an ADSB rebate program with grants available of up to $5,000. So this technology may aid in alerted see and avoid and identifying the location of other aircraft. So please take advantage of that funding that's available. More information on that rebate program is available from business.gov.au for those who aren't aware of that scheme. Passing on to Jill to wrap up.
Thanks, Cody. I think the points there are fairly self-explanatory, but I think the key is planning, as we've said, planning to know what you might expect to see at that airport. Can't always plan for everything, but at least if you have an idea of what you expect could be operating at the airport, you can plan to manage how you're going to interact with that other pilot, understanding their needs. So understanding the lack of visibility that they might have, or the manoeuvrability issues they may have, the reason why they might be flying a closer or a further out circuit, and communicate, particularly when you're in the CTAF, not to overwhelm the frequency, but simply to make sure that you are communicating with any other aircraft in the circuit so everyone knows what's going on. There's no unexpected exciting moments. Don't forget to look out the window. Obviously not quite so easy for our IPT brothers and sisters, but just keep an eye out for aircraft. Avoid the distractions and do the standard procedures that everyone's expecting you to do. So I'd just like to thank CASA for putting on this webinar. Appreciate being invited, and I hope that we've been able to give some useful points to people. I'll hand back to Cody.
That's all from my perspective there. Thanks, Jill, and thanks for having us. Thanks for tuning in.
Thanks, Cody and Jill, for that excellent presentation. That was fantastic. There was so much good information in there. One of the main themes that I really liked was being considerate and having some understanding for the other airspace users that are sharing the airspace with us. It's really important we do that. We understand what their priorities are, what their safety considerations are, what they need to do and what they can do. And it takes me to one of the questions that we got in advance about helicopters. We had a question asking if it's okay for helicopters to track directly to a non-controlled aerodrome and depart directly from the helicopter landing site rather than conduct the circuit procedures. It's a really good question, and it's covered in the good old VFRG. If you have got one of these, it's page 339 to 341. So if you do operate at a field where there are helicopters, and that is a consideration for you, they are allowed to do it. Obviously, communication has to surround that and the traffic picture has to be suitable for that to occur, but they can do it. So if you are a fixed wing pilot wanting to understand more about what your helicopter colleagues are doing, VFRG page 339. Craig in chat had a question about the wake turbulence separation, and hopefully the links that Cody and Jill provided there and Michael put in chat will help you there, Craig. If you have any further questions, you can give us a buzz. Ladies and gentlemen, does anyone have any questions for Cody and Jill specifically before we open it up to general questions? You can either chat, put them in the chat box, or indicate with a hands up. And if you have any general questions at this point, you can ask them now. So if you've got any questions for any of our three presenters or for the CASA representatives that are here today, you can indicate that now with your little hand button. Okay, well, looks like no questions. Sorry, Jill.
Sorry, it sounds like we've nailed it. No questions.
Yeah, you have. You've covered everything. It must have been a good job. No questions. And that's great. Ladies and gentlemen, you might have questions later. As I mentioned, we've put our email address in the chat there. Feel free to talk to us anytime if you've got any concerns or any questions about this sort of stuff. A couple of major points. We do need to acknowledge that operations at non-controlled aerodromes are one of our most hazard-rich operations in Australian airspace. We need to acknowledge that, and we need to listen to everything that was said today by our presenters and work that into our presentation, into our flying, I should say. So can I thank everyone who attended today for your time? We really appreciate that. We know you're all busy. Can I give a particular thanks to our presenters for their three excellent presentations? Really got a lot out of that. Even people who've been flying for a long time, I'm sure, got good information out of that. And today was recorded, as we mentioned, so you will be able to watch that back and get those little details that you may have missed first time round. Hopefully we're all walking away today with a better understanding of what the challenges being faced by our fellow aviators are and what their priorities are and what we can do as aviators to make their life easier and obviously make our operations smoother and safer. So I wish you all safe flying. Thanks again for attending, and we look forward to seeing you at future events. Thanks again to our presenters.